So first let's talk about a quick introduction to how the course will look like and what skills are expected. Okay, so guys, this course is mostly on machine learning. Okay, so machine learning, or you can say data science. So these are the same terms. These are all basically synonymous with slight differences in them, often confused. Okay, then you also know it as analytics. Okay, so what is data science? So data science is a superset basically. It's a superset which includes machine learning. Okay, machine learning is we will see what machine learning is basically. So machine learning is when you train models, and the models basically help you to get insights out of your data. Okay, so that is machine learning. Data science, it's a superset which includes ML, analytics, everything. Okay, so data science includes statistics as well. Analytics is more used in the business scenario. Okay, this is closer to the business. And data science, you can say it's closer to statistics. Okay, and ML is nothing but a subset of data science. So these are almost the same terms, not much difference between them. So people often wonder why do we have so many names for the same thing. Okay, okay, now let us see what skills will be required to do well in analytics. Okay, so the first skill that we'll be using is maths. Okay, this is the most important skill to be good at machine learning or analytics. Okay, now why do we need maths? We will talk about this in details, but just to give you a heads up, see, whatever algorithms we build, these will all be mathematical equations. So we'll be talking about a lot of algorithms later. So these are all mathematical functions. So that is why you should have a very sound understanding of the basics of mathematics. And which basics specifically? So specifically we need linear algebra, we need calculus. Yeah, so these are the two things that we'll be needing a lot. Okay, linear algebra and calculus, and of course we need probability. We need probability also. Okay, so these are the three specific mathematical skills that we will be needing to do good in data science. Okay, so I'll be covering everything from scratch, so you need not worry. Whatever maths concepts is required to understand machine learning, I'll be covering that from scratch. Okay, now let's move to the other skill that will be required. So outside of maths we'll be needing statistics. Okay, apart from maths we will also be needing statistics. So statistics is again the science of numbers. Now which concepts in statistics we'll be using? So specifically three types of statistics we have. One is called descriptive stats. Okay, so what is descriptive stats? Descriptive stats is when you describe a population with numbers. That is descriptive statistics. Okay, again these are just heads up which I am giving. We'll be talking in details about them. So descriptive stats is when you describe a population with a numbers. So let's say you have a population of students, and you want to know their age, so you will describe the age by the average age or the median age or any other numbers like that. So that will come under descriptive statistics. Then we have the probability theory. Again, probability can be included in both stats and maths. And then you have the most important part, which is inferential statistics. Okay, the most important part of stats is inferential statistics. Now what is inferential statistics? Inferential statistics is when you study a sample, of population and make conclusions about the population. Okay, so let's say you have been asked to, let's say, find the average salary of an engineer in Bangalore. Okay, you cannot go and ask every engineer in Bangalore what is his average, what is his salary. So what you will do is you will select a sample. So this is your population. You cannot study the population because you are limited by resources. So what do? You study a sample. You study a sample, a small sample, and then you make conclusions about the population. So for example, exit polls. in exit polls, when the news channels, they basically forecast which party is gonna win how many seats. They don't ask every person who has voted, they just ask a sample of voters. Okay, and then they make those conclusions, then they extrapolate the result on the population, so that falls under inferential statistics. So that also will be required for doing good in data science. Okay, and then finally you have the coding part. Finally you have the coding part. Now of course the maths that we'll be doing, the stats that we'll be doing, will not be doing it on paper. We'll be using a computer to do it, and that is where the coding comes into picture. That is why we need coding, because we have to do all of this using a computer. So for this you can use R, you can use Python, SAS is used, few people use MATLAB, you can use Java, or any other language you can use. But of course the most famous ones are these. Okay, but again, this alone is not the only component to do good in machine learning. The major component, in fact, the foundation is these two. This is just a tool that you use to apply your maths and stats skill. Okay, so in our course we'll be focusing a lot on the maths and stats part also. Most other courses, if you go, they just focus on the coding part. They don't tell you what's the maths underlining any algorithm, what is the stats. They will not be telling you. We will try to cover that as well. Okay, and of course you have your machine learning skills finally. So finally you have your ML concepts. Okay, so this one, so 1, 2 and 3, these remain the same irrespective of any language. These three things don't change. Languages can change. You might be working on R now, later you might want to learn Python, or you might want to learn SAS. So that's your choice, but these three things will remain the same. These three will not never change. The maths and stats of course will remain same irrespective of the language that you're using, and the ML concepts also remain the same. Okay, the coding syntax might change depending on the languages, but if you have solid understanding of these three things, language will not be a constraint for you. You can quickly learn whichever language you want. And most languages, you see, R and Python, at least they are very similar. They are very similar. If you learn one, you can easily learn the other. So it becomes very simple. They have similar syntaxes, similar way of writing the codes and all. Okay. Okay. So this is how it will go. Okay. Now the first few classes, so let's say first 10 to 15 hours of the class, we'll be spending only learning R as a language. Okay, before we jump to any machine learning or maths or stats. Because why is this important? Because first we should understand the language. So as I mentioned before, we apply all math, stats and ML using the language, right? Now first we have to learn the language for that, so that when we apply the maths, it will not, basically language will not be an issue for us. Whatever we want to apply, we will be able to easily apply it using the language. So that is why we will first focus on the language. And I think 10 to 15 hours, maybe 2 to 3 weekends is more than enough for you to become quite proficient in R. Of course you will go on learning as the course proceeds, but first 2 to 3 weekends will be more than enough. So 10 to 15 hours if you devote in R, you will be quite proficient. And you don't need R as a software engineer would need. Okay, you just need the basic working knowledge of R. Of course if you know more, it will always help you, but if even if you know the basics, then you can do good in data science. You don't need to be knowing a language like a software engineer does. Okay, that much is not required. Just 1 minute guys, Anand is not able to log in, so let me help him out. So I'll be on mute for 2 minutes. Okay. Okay, sorry guys. So yeah, that's how we will be proceeding. Okay, so first few days you will be looking only at R, and again, if I only cover R for entire 3 hours of the class, some of you might get bored, right? Or most of you might get bored because it will be like a software engineering class where we will be talking about a language. So what I will do is, uh, intermittently I will be introducing some basics of statistics and maths. Again, the maths will come once we start with machine learning, but in the middle I'll be introducing some statistics also. Some very basics of statistics I'll be including as we go, so to make the class basically interesting. Okay, all good guys? Okay, wonderful. So guys, yesterday I sent out a mail to install softwares, right? So if you have installed it already, or when you are going to install it, so please have it installed today. Try to install it after the class. And if you face any issues tomorrow, we can discuss. I don't think you will face any issue. It's pretty simple. But install the softwares in the same order. Okay, I have sent out one link first and then the second link. So please follow the same order. Otherwise, it won't work. So RStudio needs our console to basically run. So first you will have to install our console, the first link, and then you will have to install the second. So RStudio, it will look something like this. When you open RStudio, this is the icon. So this is the icon for RStudio. This one, it's right here. Okay. So once you install RStudio, it will look something like this. Now let's discuss what is this. So let's discuss what are these windows. Now this is the console. Okay, what you see here, this particular window is the console. This is where your codes will run. Okay, this is where your codes will run. This is your environment. This window that you see, this is the environment window. So whatever variables you create, let's say you create x is equal to 2, that means there is a variable x which has the value 2. So that x you will start seeing here. So whatever variables you create, that will be shown here, just to help you understand which variables have you created, which variables are currently loaded into memory. So all those things you will see here. Okay, then this window that you see here, so you see a few windows here. This is your files. Okay, so what is this files? This files will basically tell you what are the other current files in the same working directory that you have opened now. So by default, whatever is your working directory, so working directory is nothing but it's like which folder are you accessing currently. So people using, if you have Unix, if you have used Unix, sometime you'll understand what is a working directory. So you change the directory in Unix and go to a particular folder, right? So that particular folder, whatever files are present in that folder is shown here in these files. Okay, next, plots. So as a data scientist, we'll be drawing a lot of plots. Okay, plots help us visualize the data and help us understand better. So whatever plots you draw through codes will be shown in this window. Okay, so this will come as we draw some plots. You will see those plots coming in this window. Then you have packages. Again, packages. So the only reason why R is so famous, R and even Python is so famous, because they have something called packages. Okay, so let's say you want to do some complex analysis on in R. Okay, so if you want to do complex analysis in R, you don't have to write codes from scratch. Okay, so you can use these packages. These packages are nothing but a collection of codes which do a particular thing. Okay, these are collection of codes which somebody has written and open sourced it. So let's say you're trying to do some bank analysis, or you're trying to do let's say linear regression. So linear regression is a machine learning algorithm. Let's say you're trying to run that algorithm. So if you want to run that algorithm, you don't have to write codes from scratch. Somebody would have already written codes for that, and given you just a piece of code and just the syntax. So what you will do is you will download the corresponding package and start using those codes. Okay, and these are all the packages that are present in R. So there are around 5,000 packages, but we don't have to know all of them. Some 15-20 packages is more than enough. Okay, so these are all the packages. So you will go, so as we go ahead, you will know these things. Okay, then you have the help function. So help, to get help in R is very simple. You just write question mark. So I'm showing you, you just write question mark and whichever function you need help on. So let's say I don't know what is sum. I don't know how to use the sum function. So I don't know the syntax of it. So what I will write? I will write question mark sum. You see, this opens. Sum of vector elements. The help page opened here. So it is showing me the syntax here. And it will show some examples also at the end. See, here are some examples at the end. So this is how the help page works in R. Okay, you just write question mark and the function on which you need help. So let's say you remember some function but you don't know the syntax of it. What is the syntax of the function? Just write question mark and the name of the function, and you will have the corresponding page open here. Or you can go to Stack Overflow also, or Google it. But within R, if you want to do, this is how you do it. And you don't need Google for this. This is already installed it while you installed R. So without Google also you can get help. So if you don't have internet connection, you can still use this. Okay. Okay, viewer is something which you can ignore. This is not required. So these are the few plots that we have here. Now let's see, where do we write our codes. So whatever you write in console, whatever you write in this particular window, in the console window, so whatever you write in this window, this cannot be saved. Okay, whatever you write in console, it cannot be saved. So what we do is we open a script file for that. If you want to save anything, we open a script file. So how do we open a script file? We go to file, you will see some options. We go to new file and R script. Okay, so the moment you do this, see a script file opened. So I have a script window now open. This is my script window, and this is what I'll be using to write my codes. Now I have basically 4 windows. This is window number 1, this is 2, I have a third window here, and I have a fourth window. Okay, so I'll be writing my codes in this first window. So let's see. So I can write, for example, 1 plus 1. Okay, I can write 1 plus 1. And how do I run this? So to run any line of code, what you need to do is you just press Control Enter. Okay, Control Enter. If you press Control Enter, the entire line will be run. Entire line. Okay, Control Enter. You press Control Enter to run the entire line. Okay, so 1 plus 1, I will press Control Enter and I will get 2. And guys, ignore this red color warning that I'm getting. Okay, so my R version is pretty old, that is why I get this warning. You guys won't be seeing this warning on your system. So 1 plus 1, Control Enter, it will give me 2 here. So this is the output. So whatever codes I write in my script file, so this is my script file. Whatever codes I write on my script file and I run, that will run in console. So this is like the compiler. All the codes runs here, and you will see the output here. Now what if you want to run multiple lines of code? So let's say I have written here print. Let's say I have this now. So if I want to run this line, I will run Control Enter. And you don't have to be towards the end of the line or towards the middle. You can be any place within the line. So just be anywhere in the line and press Control Enter. So the line will execute. Okay. Now what if you want to run multiple lines? What you can do is just select all the lines. So for example, I want to run 2 lines here. I will select both the 2 lines and I will do the same thing. Control Enter. So both lines will run. Okay. Or what I can do additionally, I can press this button also. You see this run button here? I can press this button also. That will also work. Or Control Enter works. So alternatively, I can select this and I can press on run. Then again it will run. Okay. And let's say I want to save this file now. So if I want to save this file, you can see this save button, or you can press Ctrl S. Moment you do this, it will ask for a location. Where do you want to save this file? You can give any name you want. So let me go to this folder, and so day one, I'll just save it as temp. Okay. So I'll give a name temp here, and all R files will have a .r extension. You see this particular file, it has a .r extension. That is what all R files will have an extension. So temp, I'll just click save. So now you see the name change here. It became temp.r. Okay, it became temp.r. So this is the extension of all R files. So guys, that is how this RStudio looks like. Okay. Now there are several other features that are present in RStudio. So you can see here, save as if you want to rename, if you want to print. If you want to change the font and looks, you can go to global options. You can go to tool, global options, and then from there you can change all the look and feel of R basically. So this is how it looks like. So by default, so if you go here in appearance, you can change the look and feel. You see, if I click on some other places, the look and feel, you can give different colors that you want. So whatever you feel like, you can change the font size from here and so on. Okay. Okay. Now if you see, when I click on save as here, it is taking me to this particular folder, right? It is taking me to this particular folder. That means this folder is currently. So let's understand the concept of home directory first. Okay. So to get the current directory where this file is located, this particular R file, temp.r, where is this file located? So to get that, you can write get working directory and open close braces. Okay. Get working directory, open close braces. When I run this, it will show me the location that my current working directory is this and my documents. So my documents is my current working directory. So it is not this folder. It is not this folder. So what if I want to change my working directory? If I want to change my working directory to this particular folder, how will I do that? I will write a command set working directory. Okay. And within quotes, I will give the location. Okay. So get working directory is used so to view the current working directory. Okay. So this is used to view the current working directory. And if you want to change the current working directory, you use set working directory. Okay. Simple. Now there is a catch here. When you want to set your working directory, you cannot use the Windows syntax. So what I did is just copied the location from here, right? But Windows syntax doesn't work in R. It follows the Unix syntax. So I think some of you would know Unix syntax is slightly different than Windows syntax. Unix syntax follows forward slash, not backward slash. So this is a backward slash which Windows follows, but Unix syntax follows forward slash or double backslash. So what I'll do is I'll just change it to double backslash. I'll change it to double backslash everywhere, and then I will run this. Okay, so now I ran this, it ran, it did not show anything. Now if I check my set get working directory again, it will show the new location now. Now you see the output, it is showing the new location. Okay. So did you guys understand this? How do we change our working directory and all? Yes, Sukesh. Hash is used to give comments. Okay. Hash is used to give comments in R. I think hash is used in most languages. Okay. So this is how you set the working directory and all. All clear till now, guys? Okay, great. Now let me open a file which I have already written basically. So this is how the course will proceed. Okay, at least for this month. So this is what I have planned. So this is your first day. This is today. So I will try to look at these topics. Okay, and here I'll have the link here. So once I upload the files on YouTube, I'll upload the recordings of this class on YouTube. So the recordings will be pasted here. Okay, and of course shared with you. So later in the class it will help you, because whichever topic you want to revise, you can directly refer this. So these are the topics that will be covered in today's class. So let's say if you have a doubt in any of the topics here, you can directly come and look here which topics were covered and watch that particular class accordingly. So later in the class, when we have, let's say we are at day 15 of the class. Okay, so day 15 we might have covered a lot of topics. So how will you revise then? Let's say you have a doubt in one particular topic, how will you know on which day was that topic covered? So this will help you at that instant. Then you can quickly go and refer to the topic where you have a doubt and watch the corresponding day's video. You don't have to basically struggle and watch all the videos. Okay, and if I show you the homeworks that I'll be sharing a lot of homework. So because this is a weekend only class and you will get 5 days of time to practice. So a lot of homework I'll be sharing, so you can see a lot of homework. And this is not the complete list. I'll have many more coming. Okay. So this will help you basically practice whatever we are covering in the class. So it will give you a good hands-on. And of course, towards the end, we will have a list of interview questions also. And whatever interview questions I share here, 70% of the questions that are asked in interview in most companies will be from this list, the list that I'll be sharing here. Okay, around 70%. Of course it varies, sometimes it might be 90%, sometimes it might be 50%, but this is like an exhaustive list which I have prepared based on my experience, of giving interviews and taking interviews also. So I take interviews at my company. So based on that, and I interact a lot with my past students. Okay, with my students, with my colleagues. When my students go to any company for interviews, and I ask them what questions were asked, and if it is something new, I note it down here. Okay, so I've tried to prepare an exhaustive list. And trust me guys, later you will realize, once you know all the concepts, there are not a lot of questions. There are around 100 questions, you can say. A list of 100 questions. If you know the answers to those 100 questions, you can clear any interview. Of course, I'm not talking about very big companies like Google and Facebook. No. But in general, all the other companies, you can clear their interviews. Of course, if you want to clear the interview at Google, it requires extra caliber. So, yeah. Okay. Okay. So let's get going ahead. So how do we change our working directory? I have already shown you. We use set working directory command to change our working directory. Okay. So we'll be using this. So I think I changed this location. So let me change this. I'll change my working directory, and I have to follow the Unix command. Okay. Now what is this piece of code? Now when you're working in R, sometimes you will be creating a lot of variables. Let's say you are practicing and you will be creating a lot of variables. Let's say if you want to delete all the variables, you delete all the variables which are loaded in the memory currently. You want to free up memory. So what you will do, you will use this code. So RM, it stands for remove. Okay. So you are trying to remove list is equal to ls. This will give you all the variables currently loaded into memory. Okay, this piece of code will give you all the variables currently loaded into memory. So if I run this, and then if I run list, so I don't have any variable, it is showing character 0. So that means I have no variables into memory as of now. So there is nothing to delete. But if you want to delete, you can use this piece of code. Okay, so let me create something. So this console that you see here, the console that you see here is all, it also acts like your rough page. It also acts like your rough page. How? See, if you want to if you want to do some, let's say, temporary code, if you want to check, you don't have to write it here. This is all the fresh codes you will write here. But if you want to do some rough, you can write it here. Let's say I want to write x is equal to 2. So I will just write it here. I will not write it here because I don't want to save this. I don't want to save this. I just want to check, or I just want to try out something. So I will try it here in this console. Okay. So I have created a variable x which has value 2. So now you will see that x is here. See, that x has started showing in the environment window because I just created a variable. Okay. Similarly, you go on creating variables, it will start showing here all the variables that are currently loaded into memory. So now if I run the same list command again, it will show me there is one variable in memory. So let me write list. So it is showing me one variable which is x. So I can run this command now to delete. See, it got deleted. That variable x got deleted. So this is how you delete variables loaded into memory to free up space. Okay. Now let us see how do we install packages. So let me explain in details the concept of packages. So as I told you, the biggest advantage of using R is the packages. And why I told that you require minimal coding to become a data scientist, the reason for that is also the packages. So what are these packages? Okay, so packages are nothing but collection of codes. Collection of codes to do a particular task. Okay, so these are a collection of codes to do a particular task. So this helps you. You can utilize these packages. Okay. Instead of writing codes from scratch. So you don't have to write codes for scratch. You can utilize the packages basically. So let's say we are talking about an algorithm. Let's say we are talking about an algorithm which does some complex operation. So how would you do that? So if you were a software engineer, you will start writing a function, right? You will write a function. So let's say you write a function called some. You write a function, you give the name of the function, you decide what are the inputs to the function, right? You decide what are the inputs to the function, and then you do some complex operation here inside the function, and then you return the output. You return the output of the function, right? So whenever you call this function, you get this output. So let's say you have used this function, but let's say you feel that it will help a lot of other people. So other people are also writing the same function. So what you can do, you can publish this as a package. You can publish this function as a package. So that is what is a package. Okay, so package is a collection of complex functions. So next time when somebody else wants to do the same operation like you have done here, he need not write this code from scratch. He can directly use the sum function. He can directly use this function. So first he will have to install that package, and then he can directly use the function. That is why I say you need minimal coding in R, because you can utilize these packages. Because whatever you want to do, whatever complex statistical analysis you would want to do, already somebody would have done that. Okay, and all basic to complex level algorithms are already published as packages. So you don't have to write things from scratch. You can always call a package and use the functions inside the package instead of writing everything from scratch. Okay, so that is why packages are very helpful in R, and we'll be using a lot of these packages. Okay, so for example, I have tried to show a package here. How do we install a package? So ggplot is a package which we use for visualization. Okay, visualization is very important in data science because it helps you understand your data better, and it also helps you convey your message to a non-technical audience. So in data science we try to get insights from data, right? So whenever you want to convey that information, you cannot show a piece of code to somebody. Let's say you have to convince your leadership of a decision which you feel will enhance your profits. You cannot give a piece of code to your leadership. They will not understand codes. They are business people. So what you will do, you will use visualization to convey the message. So visualization is very important, and that is why you have tools like Tableau, ClickView, and so on. That is why they have become so famous. Okay, so how do we install a package? We use this function, install.packages. Okay, and then you write the name of the function. So if you see here, I'll start writing install.packages, and you see the very good thing about RStudio is it has IntelliSense. So if you write a piece of code, it will show you the options. Okay, so for example, the moment I write install, it is showing me two options: install.packages or installed.packages. So you can just use tab. So you can shift here using the arrow key, whichever you want, and it will show you the help page also. You see, it is showing me the syntax. It is showing me the syntax of it. Okay, and whichever you want to basically use, just press tab there or press enter, and that code will come. So this is one of the reasons why we are using RStudio and not R console. Okay, because R console does not have IntelliSense, so it becomes difficult. Sometimes you have to remember the exact syntax, but if you have RStudio, you don't need to remember the exact syntax. Even if you know the initials, you can understand basically. Okay, so install.packages is used to install a package. You write install.packages, and in brackets, in quotation, you give the name of the package that you want to install. Okay, so I want to install ggplot2 package. So ggplot is a package which is used for visualization. We'll talk about that in details. So I think in day 3 or 4 we'll be talking about ggplot. So this day 7 we'll talk about ggplot in details, because we have to learn visualization also in R. So that will come later, but this is just to show you how we install a package. So we write install.packages and we press Ctrl Enter. So the moment you press Ctrl Enter, it will start downloading the package from the internet. Okay, see, it is saying installing package into this particular library, and you need internet connection to install a package because it downloads from, see, you saw something getting downloaded, right? So it was downloading it from the internet, and then it will say package ggplot2 successfully unpacked and checked basically. So the package was successfully downloaded from the internet. Okay, now before we start using the package, one additional thing we have to do, that is we have to load the package. So the package is installed as a software, but we have to load the package on our current R session. In our current R session, we will have to upload the package. So how do we do that? We use a function called library. We use a library function to do that. So I will just write library and again the name of the package, and I will press Ctrl Enter. So it ran. So it ran without giving me anything. That means it worked. So now we are free to go ahead and use this package. Okay, so the package is loaded in your current R session. You can use all the functions which are inside the package now. You are free to use. So this is what is done by using these two commands. Is it clear, guys? Are you able to follow? Yeah, Jagdish, that is an important question. How do we know which functions are there in a package? Jagdish, that you will know only if you basically learn. As you go on learning, you will know which functions are commonly used inside packages, which are the packages which are commonly used. Okay, let's say you want to do something which is complex and you don't know which package is used for that. So you will have to Google basically. And with experience you will go on knowing. So we will talk about a lot of packages that are used for machine learning here, and if you want to learn something more, you basically learn it using Google. So when you want to do a complex analysis, you just Google that I want to do this, which R package is used for this. So maybe on Stack Overflow, on or on any other website, you will get that, okay, use this package, because this is a open source thing. Okay, this is not something, there is no organization which is controlling this is entirely open source. Okay, so whoever wants can publish a package, but he cannot publish an entire like he cannot advertise this, right, that I have published a package, because there is no common platform like that. So you will have to rely on Google. There is a CRAN website, there is a homepage for R, where you have a list of tasks which each packages do basically, so you can refer that also. So there is a website where you can refer. Okay, yeah, Mohit, it does show the, so if you go to packages here, it will show me all the packages that exist in R, but it will not show you all the functions inside the package. It will show you a very high level, uh, like what is that package used for, but it will not show you the functions. Okay, so for example, let's say ggplot. See, this is the ggplot here, and there is a tick mark here. This tick mark indicates that this is installed, this is loaded in your R session. This tick mark indicates that. So you see, it is written, create elegant data visualizations using grammar of graphics. Okay, this is what is mentioned here, but it doesn't mention all the functions which are inside this package. It will just give you a high level of it. Okay, so if you want to know what are the functions inside ggplot, then you will have to go to the help page of it. So let's say you can also go to the help page of ggplot. Oops. So this is the help page of ggplot. So if you go to the help page of ggplot, you will get a list of functions. So it is showing some links. So you can go to these links and basically see what are the functions, who is the creator of this package, who is currently maintaining this package. So see, the guy who maintains this package is this guy basically. And author, he was the author of this package. Okay, so you will have all the information about that package here. So you can go to this website and basically see what functions can be used inside the package. So this is how you learn basically slowly. Okay, Ankit is asking how many variables can be used at a time. Ankit, that is limited by your by your computer's memory. Okay, that is only limited by your computer's memory. There is no limit to the number of variables that you can use. Okay, great. So guys, let's move ahead now. And whenever you have to use a previously used function, you can press up arrow. So I am pressing up arrow right now, guys. You see, I'm getting the previously used commands. Whatever commands I have used in the past is all showing up. So these are some commands which I had used previously. Okay, so you can use up arrow for that. So the previous command which I used was !ggplot, so it is showing up here. Previous to that I had used library ggplot. Before that install.packages. Before that removing all files from the directory. Before that the list command. Before that I had created x is equal to 2. So all those commands are showing using up arrow key. So you don't have to write a command which you had written previously. You can just use up arrow and get it back. Okay. Okay. Now let's come to the basic operators that are used in R. Basic mathematical operators that are used in R. Okay. So arithmetic operators, same we use the equal to sign, less than equal to, plus, minus. Asterisk is used for multiplication. Forward slash is used for dividing. Percentage is used if you have to find the remainder. This is used for power. So 5 to the power 225. So for those operations we use this. Okay. Then relational we have these, not equal to, less than equal to. Logical we have and or. So we use ampersand for and we use this pipe operator for or. So this pipe operator is above your enter key. Okay. Okay. Now there are many built-in functions inside R. Okay. A lot of common things that you have, there are built-in functions. Let's say if you want to add a few items, if you want to add a few numbers, you don't have to write 1 plus 2 plus some, all of that. You just write sum and you give the numbers. Let's say 1 4 3, and when you press enter you will get the sum of it. Okay. So this sum is nothing but a function that you used, and this function is used to add multiple numbers. Okay. Similarly, there are lots of functions in R for this purpose which do different tasks. Thousands of functions. We will see some common functions. Okay. So let's start with the sequence function. Okay. Sequence function. So sequence function, what it does is, let's say I write sequence 1 to 10 and I press enter. What will I get? I'm getting serial numbers from 1 till 10. Okay. So what does the sequence functions do? The sequence function, it takes two inputs. One is the starting number, one is the ending number, and it basically creates all numbers between the starting number and the end number in increments of 1. Okay, that is what the sequence function is doing here. Now let me write something like this: -10 and 2. Now what will I get? I will get in decrement of 1. So -10, -9, -8 and so on. Okay, till 2. Okay, so this is the purpose of sequence function. Now there are other variants of it. Now let's say I want an increment of 2 now. Then I will use 2 here. So it will give me in increments of 2. It will not give me in increments of 1 now. It will give me in increments of 2. So if I have to write the syntax of sequence function, if I have to write the syntax, so sequence, you write the starting number. This is the starting number. This is the ending number. And this is the increment. What increment do you want? That is the increment here. Okay. This is the sequence. This is the syntax of sequence function. So same for the negative example. If I write, let's say 3 here, I will get in increments, in decrements of 3. Okay. I'll get in decrement of 3 now. Now what would happen if I write something like this? -10 and I write, let's say I write 1 and I write -20. Now what will I get if I run this, guys? What do you think? I've given sequence 1 -20. What should I get here? Okay, showcase says decrement from 1 to minus 20. Okay, but okay, okay. So yeah, those who are saying it is an error are correct. So let's see what it is giving me. 1, 0, minus 1, minus 2, minus 3 till minus 20. So it is doing a decrement. It is doing a decrement of minus 1. Okay, so this is not a error. So some of you said it is a error. It is not a error. Okay, it will start decrementing in terms of minus 1. So R is smart enough to know that okay, your starting number is 1 and your ending number is minus 20. That means you want a decrement. You do not want a increment. Okay, but if you do something like this, let's say you give 1 here, you give 1 here, then what would happen? Then you will get a error, because you have explicitly given that my increment should be in plus 1, but it is not possible, because if it adds plus 1 to 1 it becomes 2, which is outside the range. Then you will get an error. Okay, but if you leave it blank, R is smart enough to know what basically you are looking for. Clear guys, is this clear? Okay, so don't worry about these a lot. We will barely be using all of this. Okay, so Sukesh is asking what about sequence of prime number between 1 to 100. Sukesh, prime numbers you will not, prime numbers they do not follow a sequence. Now you can use only things in sequence which follows a pattern, which follows a particular increment. Prime numbers they do not have some particular increment, right? They are totally random. So let's say prime number starts from 3, from 2. So 2, 3, 5, 7, 11, and that way it goes. There is no particular sequence in between them, so that you cannot get using the sequence function. You can get odd number, you can get even number, but you cannot get the prime number using sequence function. That is not possible, because it has to follow a pattern, and for prime numbers there is no pattern. For that you will have to use this relational operators to get prime number. Okay, so for example, if you want odd numbers, even numbers, let's say between 2 to 100, then you can do this. It will give you a list of all even numbers between 1 to 100. Similarly you can do for odd numbers also, but prime numbers they don't have any particular increment, right? So you cannot use that for prime numbers. Okay, okay, and these are some built-in functions in R. Okay, so next let's move to some built-in functions in R. So log of x, whenever you want to take log of something, you just write log and in bracket you write log of x. Okay, this will give the natural logarithm to the base e. So log of x will by default take base e. If you want to take log with respect to a particular base, you write log of x and you give that base, whatever base you want. Okay, so for example, if I write log of 10, let's say, I will get 2.3, because right now the base is e, the value e, Euler's constant, okay, which is equal to 2.7 something. So that is my base, it is giving me the value. Now let's say I want to take log of 10 with the base 10, then I will write this, I will get 1 as the answer. Okay, or I want to take log of 10 with the base, let's say 2, then I'll write log 10 then comma 2, and so on. Similarly, if you want to take the square root of something, you just use the sqrt function, sqrtx. So sqrt of, let's say, 25, you will get 5. Or alternatively you can also use 25 to the power 0.5. You can use this also. Okay, both can be used. Then you have the factorial of x. This will give you the factorial. So very simple. So factorial of, let's say, 3, it will give you 6. Now floor and ceiling, floor will give you the immediate whole integer which is above the particular number. Okay, so for example, if I write floor of 2.3, it will give me 3, sorry, 2. It will give me the floor, the immediate number which is below the decimal place that you have written. So floor of 2.3 is 2, floor of 5.9 is 5, and so on. Ceiling will give you the immediate next whole integer, immediate next, which is higher to the number that you are writing. So ceiling of, let's say, 3.2 will give you 4, the immediate next number. So these are pretty simple commands which is present in, I think, all the languages. So nothing fancy here. Now to round off a number, we use the round function. So round the number, whatever number you want to round off, you write that number, and then how many digits do you want. So let's say I want to round 3 point, let's say I give some number, and I want to round it off till 2 digits. Then I will use this. It will round off this number to 2 digits. Okay. Now writing these digits is optional. You don't have to write these digits. You can directly give 2 here. That will also work. 2 or 3 or whatever you want, you can directly give that here. Instead of writing digits is equal to. R understands that, okay, whenever you give something like this. To get the absolute of a number, to take the modulus, you write ABS and then the number. Okay. Run if, we will see what this does. This will give you random numbers from a uniform distribution. We will come to that later. So guys, so far is it clear whatever we have discussed so far? Great. So this was just a brief introduction which I gave. Okay, most of the things that we saw till now, we will barely be use all of that. So arithmetic, these operators of course will be using, but these functions which I told you, we hardly use those functions. Okay, but this is how I wanted to start with, very basics, what we use in any languages. Now let us start with the data structures present in R. Now this is important. This is where we learn about the important data structures that are present in R. So any language, any coding language, the strength, the crux of the language is the data structures that are used in the language. So now let us start with the data structures. So we won't be looking at a lot of data structures today. We will just look at one data structure today, and then we will do a little bit of statistics. Very basics of statistics we will see today. So the first thing, the first data structure that we will see is called vectors in R. Okay, so let me write down. Data structures. Okay, and guys, I don't use any slides when I teach. Okay, I don't have any slides. I'll be sharing these files with you, whatever I'm writing down here. So I'll be sharing these with you, so you can directly open this on your system, and these will be the notes for your class if you want. Basically, there are no slides which I make. Okay, so the first data structure that we'll be looking at are known as vectors. Okay, so what are vectors? Very simple. They're a collection of same data types. Okay, they are a collection of elements of same data type. Okay, so for example, And how are they defined? They are defined using C function. Okay. So we defined vectors using this C function. C stands for concatenate, or you can say it stands for combine. So let's see how do we define a vector. It's very simple. We write, let's say I want to define a vector x. So I will write x is equal to C and then whatever elements I want to include. So x is a vector. X is a vector which has 4 elements, 1, 5, 10 and minus 20. And if you see, they are all of the same data type. They are all numbers. Okay, they are all of the same data type. So x is a vector which has 4 elements. Okay, now there is a function in vector which is length. If I use length of x, what should I get? If I press Ctrl Enter after writing length of x, I will get 4 as the answer because the length is 4, right? 1, 2, 3, 4. There are 4 elements in this vector, so I will get a length of 4. Similarly, I can try sum of x, then I will get the sum of this vector. Okay, sum is minus 4. I can write max of x, I will get 10 as the answer. I can write min of x, I will get minus 20 as the answer. I can write mean of x, then I will get the average, whatever it is. Okay, and so on. So this is how we use functions. So we use a function and then on which do you want to apply that function. So this is the syntax. Okay. So that's what I have shown here. So vectors, the first one is I have created a vector using these. So always remember you have to use C when you are creating vectors. C means combine. If you don't use C, let's say I don't use C and I run this. I will get an error. See, I got an error. So you will have to use C here, small c, and R is case sensitive. Okay, so if it is small c and you write capital C, it will not work. You have to be correct with the cases also. So what I will do to run this line, I can either select this entire thing and press on run, or I can just be anywhere on that line and press Control Enter. Control Enter will run the entire line. So it ran this x. Now to see what are the values present in x, I can run print of x or I can just run x. Both will work. I can just run x. That will also work. Or I can run print of x. This will also work. This will give me the same output. So this is what it is printing. Okay. Now let us talk about indexing. Let's talk about indexing in R. So what is indexing? So whenever you create a vector, let's say I created a vector here. Okay. Let's say I create a vector with text now. A, B, C. You can use both double quotation or single quotation. Both will work. Okay. There is no difference between the two. You can use any of them. So let's say I have created a vector which has 3 elements, and this will work because all 3 elements are of the same data type. Okay. Now there is a concept of indexing in R and in most languages. Indexing is nothing but how do you access individual elements. So the index of the first element is 1, index of the second element is 2, index of the third element is 3, and so on. Okay, so you can use the indexes if you want to access any particular element. Okay, and how do we use indexing? We write the name of the variable, or the vector, whatever it is, and in square brackets we write the index number. Okay, in square brackets, always remember we use square brackets for it. So for example, if I want to access, let's say B, I will write x comma bracket 2, x bracket 2. If you are right, I'll get B as the answer. Okay, so this is how you use indexes in R. Okay guys, so let me show you this. So I'm creating another vector here, course name. I have given two characters here, one is 02 and hero. So I run this. When I print course name, I will get both the elements. And now class is used when you have to know the data type of a variable. Let's say you want to know the data type of a variable. What is the data type of a variable? You run class and the variable name. So the moment I run class and variable name, I'm getting character. So this is a character, right? A vector of characters. So it is showing me character. Now when I run this, what happens? See, what am I trying to do here? I'm trying to create a vector called temp. Okay, I'm trying to create a vector called temp which has some numbers and one character. So Bangalore is a character, but these two are numbers. So what would happen when I run this? Anybody? So you saw the definition of vectors, right? The definition of vectors was it should have the same data type. It should have same data type. Okay. But what I'm trying to do here is I'm trying to mix the data types now. So will that work or will it throw an error? What do you think? Okay. Okay. So most of you are saying it is error. Vikas says it will work. Okay. Okay. So guys, this will not throw error. Let me show you. When I run this, it ran. See, it ran. But when I try to print it, yes, exactly, Neha, you are right. But when I try to print this, what will happen? See, it has converted the numbers to string. When I try to print this, one has become a character now. It has put double quotes on one. Similarly, it has put quotes on 2, 3, 4 also. And Bangalore previously only it was quotes. So it has converted my numbers to characters. So that is what R will do. If you try to mix up the data types in a vector, it will convert the numbers to characters. Okay, why does it convert the number to character and not the character to a number? Of course, because Bangalore it cannot convert to a number. What number will it select? It won't go for the ASCII values and all. Okay, that doesn't happen in R. So the easiest option is to convert the numbers to character. And finally you will have the temp variable created which has the same data types, which is the requirement for vectors, right? Vectors must have the same data type. So it has forcibly converted the numbers to characters, and you have a vector temp which has the same data type. So if I go and see the class of temp, I'll get a character again. Okay, so this is what happens. Okay, when you try to mix up two different data types here, this is what will happen. Okay, and as I said before, most languages in data science are the same. So a similar thing happens in Python also. There is a concept of arrays in Python where the same thing happens. Even in arrays this will happen. Okay, now let's okay, now when you print temp, what do you see? You see that there are three elements. First element is 1, second element is 2, 3, 4, and third element is Bangalore. Now let's say I write temp of 4 here. If I write temp of 4, what will I get? Because the fourth index does not exist, right? I do not have anything at the fourth index. So what should I get when I run this command? What do you think? When I run this line number 31, what should I get? Okay, Saraswati says null. Mohit says error. Any? Okay, let's see. So when I run this line, I will get NA because that value does not exist. I will not get an error, but I will get a NA because that fourth index does not exist. So NA. Okay. So NA and null are basically the same. So Saraswati, you are also right. Null is nothing but a NA only. Okay. So all missing values are represented as NA in R. All missing values will be represented as NAs. Okay, next I am trying to create another vector called x which has these 5 elements. Okay, now when I want to access multiple elements, let's say I want to access elements from third index till fifth index, I can use the semicolon for this. Not semicolon, sorry, it's colon. I can use the colon for it. Okay, colon, what does it mean? So the moment I write 1 is to 4, what will it give me? It will give me 1 2 3 4. So it is just like the sequence function, but in sequence function you can change the increment size, right? You can decide that you want the increment by 1 or by 2 or any other number. But colon function will always increment it by 1. Okay, always. So you can give -4 is to -1. It will give you in increments of -1. So it only does increments of 1 or -1. Okay, this is also 1 only, not -1. Okay, so colon will always do increments of 1, not any other number. Sequence can do increment of whatever you give it. So when I write 3 is to 5, I will get 3 4 5. So that means when I run x 3 4 5, I will get 22 23 24 out. Okay, so for example here, if I want both b and c out, if I want both b and c, what will I do? I will write x 2 3. I will write like this. I could have written this also. I could have used the sequence also here. I could have used, let's say, 2 and 3. Okay, 2 and 3, why would you be using this? I could have used this also. This will also work. This will also work. Or let's say there were some more elements here. There were some more elements here. So I could have used 2 is to 4 here. And similarly, I could have used sequence 2 and 4 also. So this also is equivalent to writing x 2 3 4, right? And this is also equivalent to writing x 2 3 4. Okay, but one thing to note here is you cannot write x 2 3 4 like this. You cannot do this, will be error. Okay, why this will be error is because you will have to use the c function whenever you are using a group. Whenever you are using more than one element, you always have to use the c function for it. Okay, even if it is inside indexes. Okay, so here when you write 2 is to 4, that intrinsically by default has a c function outside. By default you don't write it, but by default there is a c function inside, and that is why it works. Okay, so for example, let's say if I write x is equal to, let's say, some big number. Okay, now if I write x, I write 2 3 4 5. If I run this, I'll get error, incorrect number of dimensions. See, R is not able to follow that. What is 2 3 4 5? So instead what I will do, I will just use the c function. If I use the c function here, it will work. Now it will work. Now it is giving me the second index, third index, fourth index, fifth index. So the same thing I could have done by using the colon also. So when you use colon, c is not required, because colon by default has the c option. So you can just use 2 is to 5, or you can use the sequence function. So sequence we use only comma, not colon. This will also work. So these are different ways of accessing index, using colon or sequence, or using directly writing the numbers. Is this clear, guys? So this is how we do indexing in R. Okay, how you access individual elements in R from a vector. Okay, now let's say I have a vector which has 3 elements ABC. Okay, I have A, B, C here. Okay, the index of this is 1, this is 2, this is 3. Now what would happen if I write x minus 1? What will I get? What do you think? I have written x minus 1. NA, okay. So K says it will give me a NA. Okay. No, actually it will not give me a NA. What this will do is it will give me everything but the first one. Except the first index, it will give me everything else. So it will give me B and it will give me C. Okay. Except the first index, it will give me all the remaining. You have given minus 1, right? That means you don't want the first index. Except the first index, you want everything. Okay, that is what it means. So if I run x minus 1 here, so my x is right now 2, 11, 22, 33 and 44. If I run x minus 1, I will get 11, 22, 33 and 44. Okay, this is what I'm getting. Except 2, I'm getting everything else. Okay, but remember guys, my x is not getting overwritten. Yeah, then except the second index, you will get everything else, Anand. So if I write x of minus 2, I will get except the second index. So 11 is gone now. Except 11, you get everything else, and so on. Okay. Yeah, it's here. I have given this example. All but the second index. It should be second. I've given minus 2, right? So all but the second index. Okay. Next, I have some important functions here. So for example, okay. Yes, Sukesh, why not? You can give that also. So let's say if this is my x, if I write x of, let's say, c. No, that you cannot do because you are not using c. You will have to use the c function there. So let's say you use c of 1 comma 3. What will this give you? This will give you the first element and the third element. Now you can give a minus sign here also. Let's see. So see, when you give minus sign here, it will give you everything but the first and the third. Is your doubt clear, Sukesh? Is your doubt clear now after this example? So you'll have to use C. What you have written, Sukesh, you have not given C there. So the moment you go more than one index, you will have to use the combine function. You cannot use two indexes without using combine. Combine has to be there whenever it is more than one. Okay. So this way you can do. Except the first index, except the third index, it will give you everything else when you use this command. Yes, colon gives the range, but I have not used colon here. I have used comma. If I use the colon, if I use the colon here, it will give me everything except the first, second, and third. Yes, exactly, Sukesh. That's what I have done now. You see this code? I have excluded an entire range. So first, second, third element I have excluded from this vector. So first 2, 11 and 22. Except 2, 11, 22, I have written everything else. So 33 and 44 I am getting. So this way you can play around. Okay. But remember, this is not overwriting your x. Your x still is the same. This is just printing x. When you write x minus c1 and 3, this is not overwriting your original x. It is just printing you the new output. X is still the same. If I print x, it is still the same. Okay. It is not overwriting x. So some few functions, sum of x will give you sum of x, length of x will give you 5 because there are 5 elements. maximum of x will give you 44, minimum will give you 2, mean will give you 22.4, which is the average, median will give you again the median of the vector, and so on. Okay. Now next, so I think we have learned enough of R today. Now let us see some statistics. We will see some very basics of statistics, but let's take a break before that. Okay. So 1.5 hours I usually give a break. So let's take a break for 10 minutes and then we start again. Is that okay, guys? So 9:40 we resume. Okay, guys, I'll see you again at 9:40 then. I'll mute myself and I'll pause the recordings also. Okay, let's resume, guys. So now let us see some very basic statistics. Okay. So we'll start with the stats part for today. We will first look at descriptive statistics. Okay. We will first look at descriptive statistics. Now to understand descriptive statistics, we use a few parameters. Which help us. So descriptive statistics, as the name suggests, it is used to describe a population. Okay. So let's say this is a population. You have many other individuals here. Let's say this is the age. This is the age. Let's say these are many students. And I want to know, how is the age of all the students distributed? How does it look like? Now to do this, if I have to describe the age to somebody, I will not tell everybody's age, right? I will not go and say everybody's age. Let's say if I have to, let's say I'm a school teacher, okay, and this is the age of all students in my class. I have, let's say, 100 students in my class, and my principal wants to know that how is the age varying in my class. So to answer this question, I will not take the age of all individuals in my class to the principal, right? Of course, that will not make. I'll not give him 100 numbers if there are 100 students. What I will do is I will describe the population in some few parameters. I will use a few parameters to do that. So the first parameter that we'll be using is, which is very obvious, is the average, the mean. Okay. Maybe I'll say the mean of the population, that okay, I'll go and tell my principal that this is the average age of my class. Okay. So the mean here. Next, I might tell him the minimum age, of the class. So what is the age of the youngest student in the class? Then what is the maximum age? What is the age of the oldest student in my class? Okay, I'll tell these few terms. Then I might also tell him the standard deviation. So what is this standard deviation? We will look in details. Okay, what is the standard deviation? So these are the few parameters that we will be using to describe this population. So instead of taking all the values in this population, I will describe the population using these few parameters. Okay. So this is known as, or I can take the median also. The median also. Okay. We will see what median is. Okay. So these are the few parameters which are used to describe a population. Okay. So these come under descriptive statistics. Okay. Now before we see all of this in details, let's see the concept of a histogram. What is a histogram? This is very important. Let's see what is a histogram. Okay. So let's say I ask the age of the students in the class. Okay. And let's say this is what I get. So let's say I have 25. So this is the age, let's say, and this is the count. So 25 years, let's say I have two person who are 25 years old. Okay. 28, let's say I have three. I have three person who are 28 years old. 32, I have one. Let's say 30, I have four. 36 I have, let's say, 1. So let's say this is the distribution of age in a class. This is how it is distributed. I have 2% who are 25 years old. I have 3% who are 28 years old. I have 1 who is 32 years old, 4% who are 30 years old, and so on. Okay. Now if I have to draw this in this fashion, let's say if I draw the age on my x-axis and the count on my y-axis, how will it look like? At 25, the count will go till 2, right? This is 1, this is 2, this is 3, this is 4, this is 5, let's say. At age 28, so this is 25, this is 26, 27, 28 is here. So at 28, my height will be 3, right? Okay. Now let's say next I move to 32. 28, 29, 30, 31, 32. 32 height is only 1, so it will go only 1 above. 33, 34, 35, 36, it is again 1, so it will be equal to that. And 30 I have 4, so 30 it will go till 4. Okay. Okay, so I have everything. Okay. So everybody understands this plot. How did I come up with this plot? From this table I basically drew this plot where I have age on my y-axis, on my x-axis, and y-axis is nothing but the frequency count, or I can say frequency. So guys, do you understand this? Okay. So this is nothing but this is called the histogram. This is a histogram. Okay. This is nothing but a histogram. So if I draw a curve over these bars, I can draw a curve over these bars, right? Like this. So this is nothing but a histogram. Okay. So let us see how can we draw this in our. Of course, we don't draw histogram with just 5 or 6 values. We will have many values, right? Because our population will not be so small. It will be a big population. So you will have many other bars in between. You will have many other bars like this. Okay. It will look like an entire area. It will look like, not individual bars. So let's try to draw histogram in R. Column graph. What is a column graph? Okay, so I think, do you mean bar graph, right? Bar graph, right, Vishal? You mean bar graph, I guess. It is the same. It is the same. Histogram, bar graph, it is the same, you can say. Okay. So first, let us form a vector. Let us form a vector. Okay. So let me write histogram here, and let me form a vector. So don't worry about this. I will tell you later what that runif function does. Okay. So right now what it is doing is, so runif function, what it does is it generates random numbers from a uniform distribution. So the moment I write runif, if I give 2, it will give me 2 random numbers between 0 and 1. And these random numbers will come from a uniform distribution. So if I run it again, I will get 2 different numbers. Every time I run this, I get 2 different numbers. So we will come to this later when we are talking about different kinds of distributions. But right now, just understand that this vector called x has 4,000 random numbers between 0 and 1. So x is a vector which has 4,000 random numbers. So 4,000 random numbers between 0 and 1. Why between 0 and 1? Because by default it gives random numbers between 0 and 1, taken from a uniform distribution. So we will talk about what uniform distribution is later, but as of now just assume that x is a vector which has 4,000 random numbers. Okay, and I want to draw a histogram of that. So it is very simple in R. We just use the hist function. We use hist and name of the variable, and we run this. So see, you will get a histogram. So this is how it looks like. Okay, between the numbers are between 0 and 1, and this is how the histogram looks like. So there are around 400 numbers at each interval. If you want, you can add color also here. So you can write color is equal to whatever color you want, let's say red. So you will get a histogram which is red in color. Okay, so this is how you draw a histogram in R. It's very simple. It is giving you the frequency on your y-axis, what we also saw. It is giving you frequency on your y-axis, and on your x-axis is the variable. So this can be any variable, your age, your weight, or whatever. Okay, whatever variable you are trying to study. This can be, let's say, the sales of a company, or this can be the number of employees in the company, or whatever. And this is the frequency. Okay, now there is a parameter called breaks in a histogram. Okay, now let's see what that breaks means. So I'll give a number 20 and I draw this. So what did you see? Your histogram bars became finer, it became more granular, right guys? Now let me show you. Let me change the breaks to a higher number. So right now my breaks is 20. Let me change it to, let's say, 40, and let's see what we get now. So when I change it to 40, what happened? My bars became even more granular. My bars became even more granular. So what does the break parameter do then? Can you tell me? What does the break parameter do here? It determines the granularity. Okay, it determines the granularity. If you want data more granular, you will give breaks as a higher number. Okay, if you don't want that much granular, you will give a smaller number. So if I give 10, I will get only. So what this does is it divides the area into 10 parts. So you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 bars basically. So breaks determines that. Okay, breaks will determine that. So right now I have 10 bars. If I give, let's say, 40, I will have 40 different bars. So obviously my data will become more granular. So if you have to look your data more granularly, you will use breaks and give a higher number to it. By default, R will give you some particular number. So that is also not fixed, but you can always change this. Okay, is this clear? How to draw histogram and what does the break function do? Yes, Vishal, it can be any number. Yes, Sukesh, the frequency will change, right? The frequency will change according to the breaks that you give. Okay, so let me give you an example. So let's say right now with this particular example, okay? Yes, as you move more granular, your breaks will change. So let's say right now you give a break of 1, 2, 3, 4, 5. Let's say you give a break of 5. So let's say this is my x. You will write hist of x and you give breaks is equal to 5. So what will you get? You will get these 5 bars, right? One at 25. You will get one at 28. You will get one at 30, one at 32, and one at 36. Right, this is what you will get when you give a breaks of 5. Now let's say I give a break of 2 only. I give hist x break is equal to 2. Now what would this mean? This would mean that I will have only 2 bars now. I'll have only 2 bars. So I'll have 1 bar from 25 till 30. Okay, and I'll have another bar from 31 till 36. Okay, now within 25 and 30, how many do I have? I have this, I have this, I have this, right? So 2 plus 3 plus 4. So 4, 5, 6, 7, 8, 9. So now my height will become 9. My height will be 9 for this bar. And for 31 to 36, I will have 1 and this 2. So the height of this will be only 2. Okay, so the height of this is 9, the height of this is 2. But previously my heights were different. Previously my height was 2, for 28 it was 3, for 30 it was 4, this was 1, this was 1. So of course the heights will change. Yeah, if you make it 6, it will not change. It will be the same. It will be the same as this is, because the data itself is not more granular than this. Okay. So Neha, if you make more than 6, it will still be the same because the data is not more than this. This is the max granularity it can go. It cannot go beyond this because the data itself is not available. Okay. So that's how you decide basically. No, Sukesh, frequency you cannot control. You can control only these bins. You can control only the bins. And as per the bins, you will get the frequency. Frequency, how will you control? Frequency is coming from the data. You don't have any control over the data. The data is what it is. You only can control the bins that you make here. Okay. The groupings that you do here, whether you want in groups of 1. So this is in intervals of 1, right? So 25 is separate, 26 is separate. So this is the granularity here is 1 units. The granularity here is 5 units. So you can control the granularity here. You cannot control the frequency. Frequency will come from the data. The granularity is what you can control. Okay. So that's how you draw a histogram. You can go to the help page of hist function also. Let's say I write question mark hist. Let me write it here itself. So question mark hist will take me to the help page of hist, and you see I'll get the help page. You can enlarge this using this button. You can enlarge this, and this is what you get. The generic function hist computes a histogram of a given data value. Okay, and some syntax is given. There are many other parameters also, right? You can see there are many other parameters, but I think whatever we need, breaks is what we have given. So this is what it gives. Breaks is the vector giving the breakpoints and so on. So the entire explanation is given here if you want. Okay, but that's what it basically does. It controls the granularity of your histogram, and there are many other parameters also. You can see these are all optional parameters. If you want, you can give them also, and you will have a few examples here. Okay. Now if you want, you can give labels to your histogram. So how do you give labels? You can just write x lab is equal to something, whatever you want to write. Okay, so you see Ars Intelligence, it is helping you x lab, and it is showing you the help page also of it. So it is showing you these arguments are used to title or defaults here. So what you can give, x lab is equal to, let's say you can write, what is this variable? Let's say random variables, random values. Okay, similarly you can write y lab is equal to, let's say, count. Okay, now if you print the histogram, you will have the label. See, I have random values here written. Whatever I gave as my x-axis label is here. Whatever I gave as my y-axis label is here. Okay, so you can decide the labels also what you want. Okay, and if you want to give a heading to your entire chart, that is given by the main function. So main is equal to whatever heading you want. So let's say you want to write my first histogram. Now if I run this, I will have a histogram which has a main heading also. So I'll have this here now. Okay, so this way you can customize your histogram and give whatever titles you want as per your business data. So let's say you are analyzing some variable, so accordingly you can name your histogram, and you can directly copy paste that as a into a PPT. Let's say you want to present it. So how will you do that? You just go to file, save as. Save as, you will have so many options. Save as PDF, save as PNG image, and so on. You can directly save it. Or if you want to paste it to a PPT, you can just copy it to clipboard and you can paste it. Okay, you can resize it also, and so on. So this is how you draw a histogram. So let's see what details do we get from histogram. Why is histogram used? So histograms are very important. Let's see the usage of histogram. Okay. Now histogram is used to study the distribution of a variable. It is used to study the distribution of a variable. Okay. How is a variable distributed? To study that, we use a histogram. Okay. So for example, let's say orders at a e-store. Let's say orders at Amazon. Orders on Amazon by the hours of the day. Okay. So let's say we are trying to analyze the orders at Amazon by the time of the day. Okay. So let's say this is the time of the day. It starts from 0, so midnight, till let's say 24, again midnight. Okay. So at 0 in the morning till the evening, and we want to analyze the number of orders every hour. So it will be divided into 24 hours. We have 24 hours here. So let's say between 0 and 1 o'clock. So from 12 in the night to 12 in the morning to 1 in the morning, let's say we got 10 people ordered on Amazon. 10 people purchased something on Amazon. So between 1 to 2, let's say 20 purchased. Between 2 to 3, let's say only 5 of them purchased. 3 to 4, let's say 8. 4 to 5, let's say 2. 5 to 6 is again 3. 6 to 7, let's say 5. 7 to 8, let's say 10. 8 to 9, let's say 15. 9 to 10, let's say 20 people purchased. 10 to 11, let's say 30 purchased, and so on. From 11 to let's say 12, 50 people purchased. Now you can draw a histogram of this. So it is very difficult to study or make an understanding of the orders at Amazon using this. Using this chart, it is very difficult, right? So how you can study this? You can draw a histogram to study this. So if you draw a histogram, you will have time of the day here. You will have time of day here, and here of course you will have frequency or the count. So always remember, you just need one variable to draw a histogram. Y-axis is nothing but the same variable count of it, but you need only one variable. Okay, so this will be nothing but your time of the day. So 0, 1, 2, and so on till 24, and you will get a histogram. Let's say it will be something like this. Okay, not like this. It will be something like this. Right guys, it will be something like this. So initially during these hours the orders is very less, and during the day you have a peak in your orders, number of orders, and it basically looks like this. So this is the distribution of orders at Amazon by time of the day. So using this table, it was very difficult for us to understand, right? Using this table, it is very difficult to understand. If you draw a plot like this, it becomes very easy. That okay, as our day progresses, the number of orders increases. So let's say if Amazon has to schedule, let's say the number of employees serving at that time, it can use this easily to schedule. Okay, for resource scheduling, this can be used easily. Using this table, it becomes very difficult, but using this, it is so easy. Okay, so that's one of the use of histogram. We'll be drawing a lot of histograms ahead. Okay, these are very important. Now let's say if you don't want it in granularity of 1 hour. Right now it is in granularity of 1 hour, right? At every 1 hour you have a bar basically. So you don't want that, you can reduce the granularity. So you can use the breaks parameter. Let's say you want to know every 8 hours. So you want in 8 hour shift. You know that every employee will work in 8 hour shift, or let's say 6 hour shift. So you can give breaks is equal to, accordingly you can change the breaks, and you can divide the area into 3 pieces. Okay, into 4 pieces basically. So 6 4s is 24. So you can divide the area into 4 pieces and then you can use that instead. Okay. So this is how histograms are used. Okay. Now let us come to the different types of distributions that we have, right? The different kind of, now since you know the histogram, what a histogram is, let us see what are the very basic type of distributions that we have. The first one that we'll be looking at is uniform distribution. So most of you would already know this. What is a uniform distribution? A uniform distribution is when the histogram is flat. It is straight line like this. So it doesn't change. The frequency doesn't change basically. Okay, whatever that variable is, the frequency doesn't change. It is almost the same. It is a horizontal line. That means it is uniform. Right guys? It is uniform. It is not changing. So it is uniform. So maybe for example, the cruising speed of a plane. The cruising speed of a plane is almost constant, doesn't change a lot. So let's say during takeoff it is less, it increases when the plane takes off, and then at cruise it is almost the same, and then again during landing it decreases and it stops. So during cruise it is a uniform distribution, it doesn't change. Or when you hit the highway, your speed is almost same. And of course when you are in the city limits, your speed will decrease or increase depending on the traffic, but on the highway it is almost same. So that is nothing but a uniform distribution. Okay, so uniform distribution. So how can you represent mathematically a uniform distribution? How can you represent the uniform distribution mathematically? We use just a constant. We need just a constant. So let's say this constant is k. Okay, so we can write y is equal to k. Okay, this is how you mathematically represent a uniform distribution. Y is equal to k. That means your y is constant, and you can see, right, at whichever point you go, your y is always remaining constant. Your x is changing but your y is never changing. So the equation of this line is y is equal to k. This is the equation of a straight line. So y is equal to k. So remember the equation of a straight line, y is equal to mx plus c, what you had studied in schools. So here m is nothing but the slope, c is the intercept, right? We will come to this again when we do linear regression in details. Okay, that's why I said linear algebra is very important. Okay, but right now my slope is 0. My slope is not changing, so this parameter will be gone, and c is nothing but this k here. So my equation will become y is equal to k. So this is the equation of a uniform distribution. Now if you remember, I use the command runif, right, to generate random numbers. So when I write runif 5, it gives me 5 random numbers from a uniform distribution. 5 random numbers between 0 and 1 from a uniform distribution. That means it is coming from a distribution like this, where your numbers is between 0 and 1, and you have a uniform distribution like this. So this is how the histogram looks like. Okay, and what it does, this function, what it does is it picks some random numbers, 5 random numbers from here. It will pick 5 random numbers from here and it will give me. So when I draw the histogram of that, I should get a uniform distribution like this. Are you following, guys? Since this function picks numbers from a random uniform distribution, when I draw the histogram of this function, it will give me a horizontal line like this. Okay, let's try this out. Let's try this out in R. So let's say I will create a vector called y. So I will use runif function and let's say 5. Okay, and then I will draw a histogram of y. Now right now it is not looking like a uniform distribution, right? It is not looking like a uniform distribution because we have taken only 5 numbers. So 5 numbers is very small numbers. You'll have to use a lot of numbers to finally get to the uniform distribution. Okay, so let's say I use 5,000 numbers. Then if you see, it will be almost like a uniform. See, it is almost like a uniform distribution now. It is almost like a line, like a straight line. As I increase the number of random numbers, it will go closer to a uniform distribution. Now let's say instead of 5,000 I use 500,000 now. Okay, I use 500,000. Now when I plot, you see it is very closely looking like a uniform distribution, almost a straight line. Small minor differences are there. Okay, but almost like a uniform distribution. Okay, so run, it is actually R unif. R stands for random, unif stands for uniform distribution. So it gives you numbers from a uniform distribution. If you want, you can go to the help page of it and it will show you the syntax. Okay, R. So unif, R unif will give you, the help page tells us that this is how it looks like. Okay, and this is what it is used. So minimum is 0, maximum is 1 by default. If you want, you can change it. So let's say if you want, let's say I want these 500 numbers to be between 1 and let's say 100. I want these numbers to be between 1 and 100. I will run this command. Now if I plot the histogram, it will be between 1 and 100. Now you see, I have these numbers between 1 and 100. Okay, I can give any range I want. I can give 10 and 100 also if I want, and so on. Okay, by default it is between 0 and 1, but you can change that if you want. Okay, so this is about a uniform distribution. Now let's see another distribution. We will see what is a normal distribution. We will see what is a normal distribution now. Let me just save this file. I'll open up a fresh notebook. Okay. Now before we move to normal distribution, let us see again, let's come back to descriptive statistics that we were discussing. So mean, we all know what is a mean, right? Mean is nothing but the average. Now let's see what is a median. So what is a median, guys? Can you tell me? Yes, the middle value. So median is nothing but the middle value after you have sorted the items. Okay, after you have sorted the elements. So let's say I have a vector called with these numbers and so on. Okay, so first what you do is first you sort them to find the middle value. You cannot say that 11 is the middle value here because right now they are not sorted. Okay, so first what you'll have to do is you'll have to sort them. So 1, 5, 8, 11 and then 20, and then whatever is the middle value, the value which occurs right in the middle, is your median. So your median is 8 here. Okay, so the median of this vector x is 8. Okay, now what if I had one more here? Let's say I had 25. Now there is no one particular middle value. Both 8 and 11 are your middle values. So how will you find the median in this case? In this case, how will you find the median? If your number of elements are even, then Neha, I did not understand. Can you rephrase your question? If I want these range sort with descending order, I'm sorry, I did not understand. You don't have to do that. Basically sorting it does internally. So when you use the median function, median of x, it will automatically sort and give you 8 as the answer. You don't have to do that. Okay, that is just for explanation. I told that first you have to sort and all. The function already takes care of that. Okay, so in these cases, how will I find the median? In this case, for example, where my number of elements are even. Yes, exactly. So Mohit is right. It will be the average of the middle two. Okay, so it will be 8 plus 11 divided by 2, whatever that number is. Okay, so this will be the median for this vector. Okay, so median, in another way I can say, it is the 50th percentile. Median is nothing but the 50th percentile. Okay, so that means 50% of the values are below it and 50% are above it. Okay, so anybody who has appeared in CAT, they will know what a percentile is. Okay, okay, so this is the median. Now let's first understand what is a now let us see what is a standard deviation. Okay, so now you understand. Okay, let me go it this way, not standard deviation. Let me first talk about another kind of plot called. Okay, so guys, let's discuss something called box plots. What are box plots? Okay, we will come to standard deviation and normal distribution maybe tomorrow. Okay, but first let's understand box plots. So what is a box plot? Box plot also shows you the distribution. It also shows the distribution. Okay, but it helps you to identify outliers in data. Okay, what are outliers? What are outliers? Values which are very different from others. So these are basically exceptions, or you can say anomalies, and so on. So values which are very different from other values in a, like let's say you're talking about a vector x and you have some value which is very different from the other values. That means it is an outlier. Okay, that means that particular value is an outlier. So box plots is another kind of plot which helps us identify these outliers, which will help us identify these outliers. Okay, so let's see how do we identify them. Now first, to identify them, which values will you say is an outlier? Let's say I create a vector x. Okay, I give 5, 11, 19, 200 and 1000. Now which of the values here is an outlier? What do you think? Which value here is an outlier? Hundred. Saraswati, we do not have 100 here. We only have 1000 and 200. Yeah. Okay, so you can say that 200 is an outlier and 1000 is an outlier. Okay, right? Because these two values are totally different from the other values, so we will have to check that. How do we decide that? Where is that threshold? So where is that threshold above which you will say that all values are outlier? How can we identify that? For that we use the box plot. Okay, so to understand that, we will have to understand first the concept of quantiles. Okay, the concept of quantile. Quantile is nothing but percentile. Okay, so there are three quantiles which are very famous. One is called Q1, okay, or the first quantile. This is nothing but 25th percentile. Q1 is the 25th percentile. Okay, similarly we have Q2. Q2 is nothing but 50th percentile. This is also known as median. We have already seen this. Then you have Q3. Q3 is the 75th percentile. Okay, so we are talking in terms of percentile now. Three key percentiles we use. One is called Q1. Q1 is nothing but 25th percentile. One is Q2. Q2 is known as 50th percentile, all the median. Then you have Q3. Q3 is your 75th percentile. Okay, now what is a box plot? A box plot is what gives you these distributions. Okay, so a box plot will look something like this. Okay, it will show the distribution of the variable on the y-axis. So this is your y-axis. Okay, this is your y-axis, and let's say we are talking about age right now. This, you see a box here, right? That is why it is known as box plot. Okay, so it is known as box plot and also known as box and whisker plot. Okay, it is also known as box and whisker plot. So what is a whisker? A whisker, these lines are known as whiskers. Okay, these lines are known as whiskers. So it is commonly known as box plot, but the full name is box and whisker plot. Okay, now what is this particular box? This box is starts from Q1 and goes till Q3. Okay, so this point is nothing, the corresponding value here is your Q1, and the corresponding age here is your Q3. Okay, you have your median somewhere here. This is your Q2 the median. Okay, now 50% of your data is in this box. 50% of your data is in this box, obviously, because it goes from 25th percentile till 75th percentile, right guys? So that means 50% of your data is within the box and 50% is outside the box. Okay, so 50% of your data is within the box, 50% is outside the box. Okay, now what is this distance? This distance of the box is known as IQR. Okay, or inter quantile distance. This distance, so IQR is nothing but, let me write it down here, IQR is nothing but Q3 minus Q1. That value is your IQR. Okay, this is your IQR, interquantile range. Now you might be asking what this distance is. What is this distance? Now this distance is nothing but 1.5 times IQR. Okay, similarly this distance is also 1.5 times IQR. Okay, now if I have to ask you what is the value here, can you tell me what is the value here? If I have to ask you what is the corresponding age here at this point? Now can you tell me guys? I'll tell you later why we are doing all of this. How can this help us identify outliers? Can you tell me this particular value here, looking at the y-axis and looking at these values? Okay. Yeah, this is the minimum, but can I get a equation for this? How will I calculate this? How will I calculate this median, this minimum, given that I know Q1, Q3 and everything? So I know what is my Q3, I know what is my Q2, I know what is my Q1. So can I calculate this value? What is the minimum value? This is not the minimum, by the way. You can have values below this also. Okay. So this is nothing but Q1 minus 1.5 times IQR. Do you agree, guys, that this particular value is nothing but Q1 minus 1.5 times IQR? Okay. This is the point here. Do you agree? 12.5. Arvind, what is 12.5? Okay. So this is nothing but Q1 minus 1.5 times IQR. Okay. Similarly, can I ask you what is the value of this point? What is the value of this particular point? On similar lines, can you tell me the value here? What is the Y value here? You know Q1, Q2 and Q3. Yes, exactly. Okay. So Mohit is right. This value is nothing but Q3 plus 1.5 times IQR. Okay. Because you know Q3, it is here. You just have to add this length. Yes, exactly. Okay. Okay. Now how will this box plot help us identify outliers? So the answer to that is this. Whatever outliers are nothing but values which are less than Q1 minus 1.5 times IQR, or values which are greater than Q3 plus 1.5 times IQR. Okay. So any value which falls outside this range. So this was not the minimum. You might have some values here. Okay. Similarly, you might have some values here also outside this range. Whatever values come outside this range are outliers statistically. Okay, statistically those are the outliers. So we'll have to see here. We cannot look at these numbers and directly say which is outlier. Probably 1000 is outlier, but 200 we are not sure. We'll have to check. We'll have to draw this plot and check whether 200 is falling outside this or not. Okay, so this is how we basically check for outliers. We check for outliers in our data. So any value which is outside this range are outliers. Okay, is this clear, guys, or should I explain it once again? Yeah, Neha, outlier, how did we calculate outlier? We just subtracted the 25th percentile from the 75th percentile. Okay, so we calculated the 75th percentile from our data, and we subtracted the 25th percentile from it. This is your IQR. Okay, 75th percentile is also known as Q3. This is also known as Q1. Arvind, that is a statistically derived value. There is no reason for that. Okay, so statistically it is seen that whatever value falls outside 1.5 times IQR are outliers. That is empirical value. Okay, it's like a formula. So Neha, is it clear now? How do we calculate IQR? Okay, so let's do that. Let's do that in R now. Okay, so let me show box plot. So let me create a vector. So 1 3 5 6 3 200 and let's say 1000. So this is a vector that I have plot. First let us calculate the percentiles. So let me calculate the median of it. Median of x will be 5. Similarly, let me calculate. So we can use the quantile function. Okay, quantile function will give you all the percentiles. So let's say I want the 25th percentile. So I will write 0.25. So the 25th percentile is 3. Okay. Similarly, if I want more percentiles, what I will do is I will use the C function and I will give, let's say I want the 50th percentile, I want the 75th percentile. See, it is giving me. The quantile function is used for that. You give the variable and using the combine function, you give whatever percentile you want. Okay. So I want the 25th percentile, I want the 50th percentile, and I want the 75th percentile. You give it as a proportion. You don't write 75 there. You give it as a proportion. Okay. So it is saying me that my 25th percentile's value is 3. Okay. It is saying me that my 50th percentile is 5, which is same as the median, by the way. You see here, median also gave me 5. And my 75th percentile's value is 103. Okay. Now we can calculate IQR here. What will be our IQR? Yes, guys, tell me. My IQR will be Q3 minus Q1. What is my Q3? Yes, Neha, what is my Q3 here? Vishal, that is calculated after sorting your values. So first what you do is you sort your values in ascending order and then you see below which value 75% of your values lie. That is how percentiles are calculated. Okay. So you arrange your variables in increasing order and then you check the value below which 75% of your values lie. That is how you calculate median also, right? First you arrange in increasing order and then you check below which value 50% of your values lie. Okay, that is how percentiles are calculated. Okay, so Sukesh says 100. No, Sukesh, your third quantile is 103, right? Not 100. You can see it here, right? 75th percentile is your Q3. So your Q3 is 103. So I will write 103 here. Minus, what is your Q1? What is your Q1? Q1 is 3. Yes. So you got your IQR now. So the value of IQR is nothing but 100. Okay. Your value of IQR is 100. So what will be your outliers? Your outliers, the minimum threshold of outliers will be Q1 minus 1.5 times IQR. Not getting? Okay. Let me explain it once again, guys. Okay. So to understand box plot, the first thing that you should understand is the concept of percentiles. Okay. The concept of percentiles. So what is the concept of percentiles? When I say X percentile, what does it mean? When I say X percentile, what does it mean? It means that X% of population is below that number, whatever that number is. Okay, so do you agree with this, guys? When I say that my X percentile is, let's say, 5, what does it mean? That means X% of the population is below 5. Everybody agrees with this? Do you understand this? Neha, Vishal? Okay, so how do you find this? How do you find this? So the process of finding this is you arrange the numbers in increasing order. You arrange the numbers in increasing order and see. So for example, let's say you find 50th percentile. 50th percentile of, let's say, 1, 5, 11, 21 and 33. So what you will do, you will first arrange them in increasing order. So this is already arranged. And then what you will do, you will see below which number do 50% of the numbers lie. So here that number will be in the middle of these two, right? So it will be somewhere here. Below that number you will have two number below that. So 50% of the numbers are below that. So you will calculate the 50th percentile in that way. Similarly, if I ask 75th percentile, you will see below which number do 75% of the numbers lie. That way you will calculate 75th percentile. Similarly, if I ask 25th percentile, you will see below which number do 75% of the numbers lie. That is nothing but your Q1. This is known as Q3. This is known as Q2. No, Vishal. It means 95%. What is that 95%? Q1 means 25% is below it and 75% is above, not 95. The total should be 100, right? Are you getting, Vishal? No, I think you are confusing it with the value of the number. Let me explain once again. Let's say the numbers are 100, 150, 180, 200, 101. This is my x. Okay, this is my x. I have to find the 25th percentile or Q1. I have to find the 75th percentile or Q3. I have to find the 50th percentile or Q2 from here. So how will I find now? So first let us find 50th percentile because this is very easy. So how will you find 50th percentile here? First task is you arrange the numbers in increasing order. So let me arrange in increasing order: 100, 101, 150, 180 and 200. Okay, I have arranged in increasing order. Now I have to see what is my middle number. So what is my middle number here? It is 150 because it has two numbers below it, it has two numbers after it, right? So my Q2 is 150. So my 50th percentile is 150. Okay, is this clear, Vishal? Okay, similarly I will calculate 25th percentile. So how will I calculate 25th percentile? I will see what is that number below which 25% of my numbers are present. So it probably will be 101. So I will write 101 here. Similarly, 75th percentile I will get 180 and so on. So this is how these numbers are calculated. Once you have these numbers, again you don't have to calculate this manually. You can use the quantile function for it. So quantile function also gives you the same. You write quantile and the variable on which you want to find the percentiles, and then which percentiles do you want to find. So I want to find the 25th percentile, I want to find the 50th percentile, and I want to find the 75th percentile. So that's why I have given these values only. If you want to find the 95th percentile, you can write 0.95 also. It will give you the 95th percentile. But I don't want that. I just want the first three. Yeah, that is quite possible. Saraswati, that is quite possible. So for example, let's say if I had another number here, let's say I had 190 here, then what will be the 50th percentile? The 50th percentile will be the average of these two, right? The 50th percentile will be the average of these two, because this is not the middle number and this is also not the middle number. The middle number lies somewhere in between that. So we take the average of the two. So the average of the two will be 185. So even 185 is not present in the list, right? 185 is also not present in the list, but still we got it. So on similar lines, we get a different number sometimes in 25th percentile, in 75th percentile. Okay. So that is how we got these numbers. Now it is simple. Now once you have your Q1, so this is nothing but your Q1, this is your Q2, this is your Q3. Now you can go to the box plot formula. Directly box plot tells us here in addition of 190, the example, what will be Q1 and Q3? It will change accordingly, Vishal. You can calculate that. So you don't have to calculate because you can directly use R for it, but it can be calculated. Okay, so let's say you have 100, 150, 180, 190, 201. Okay, I did not arrange it. 101 here. and you want to calculate Q1 and Q3. So total how many numbers do we have? 1, 2, 3, 4, 5, 6. We have total 6 numbers. So what will be 2/3 of this? Again, the process of calculating it is a little difficult. Okay, so I am not sure if you want to go into that, because that might confuse you more. But listen up again. Anyways, let's listen up. So what is 25% of 6? 25% is 1/3 of 6, right? So 1/3 of 6 is, no, not 1/3, 1/4. 1/4 of 6. So 1/4 of 6, how many numbers will you get? You will get approx 1.2 numbers. Yeah, 1.5. You will get 1.5 numbers. That means you have to be somewhere in middle of these two to be 25 percentile. So I think it will be 100.5. 100.5 will be your 25th percentile. Similarly, if you have to find the 75th percentile, that means you have to go 3/4 of 6. So 3/4 of 6 will be 4.5, right? 3/4 of 6 will be 4.5. That means 1, 2, 3, 4. So between these two. So it will be probably 185, somewhere close to that. Okay. So that is how you calculate your all the percentiles. Okay. Don't worry, we don't have to get into that much details. But if you want, yes, this is how you calculate. But we don't have to do that because R will do that for us. So now once you have your Q1, Q2, Q3, everything ready, now you can easily calculate your IQR. So this is my all the values. To calculate IQR, I gave you the formula for IQR. IQR is Q3 minus Q1. Q3 is the value corresponding to 0.75, which is 103, and Q1 is the value corresponding to 0.25, which is 3 here. That is why my IQR is 100. The value of IQR is 100. Okay. Now what will I say as outlier? My outlier will be all values which are below Q1 minus 1.5 times IQR, and all values which are above Q3 plus 1.5 times IQR. So what is that value? Below Q1 is nothing but Q1 is 3 minus 1.5 times 100. Okay, so same thing I can write 3 minus 150. So all values which are below 147 are outliers. Okay, this is on the lower side. Similarly, you will have a threshold on the higher side also. The higher side is all values which are greater than Q3 plus 1.5 times IQR. So Q3 is 103 plus 1.5 times 100. Okay, which is equal to 150. So this is 253, right? So my final outliers is all values which are less than 147 minus, and all values which are greater than 253 are outliers. Okay, so from this what do we see? Which value is falling in the outliers? Yes guys, from this only 1000. Yes, because 200 is below is not in this range, right? So only 1000 will be your outlier. Only 1000 is your outlier from this data. So all that calculation that we did, right, it was not necessary actually. It was not necessary because you could have used a function directly. Box plot of x. The moment you use this function, it will give you what is the outlier. See, it is giving you 1000 as the outlier. Do you see it here? It is giving me 1000 as the outlier. So you don't have to do this. We did that manually. It is good for understanding, but we did not do that manually because R will directly do it for us. So this is what is the outlier. See this point here? This is the outlier. You're not getting any other point. So see, 100 is not coming here. 100 is within this range. So this is your Q3. Okay, your Q1 is almost equal to your median, and which is true, right? My Q1 is 3 and my median is 5. So they are almost the same. That is why you see the same line here. There is hardly any difference here. Okay, so do you understand guys? Did you understand box plot? This is very important. We'll be using this a lot in the future classes. Did you understand, guys? Box plot, did you follow? Neha, any doubts? No, Vishal, you will not see in the box plot formula. In the formula, you will not see. It is internally getting calculated. Okay, but this distance that you see here, right? This is 1.5 times IQR. This distance. Okay, this distance is your IQR. This is your IQR, the box, and whatever you see above this distance is your 1.5 times IQR. Again, I can change these values. I can insert some other values in between. And I can plot it again. So now when I plot the box plot of this, I will have a different figure now. Now I have a different picture. Still 1000 is my outlier, see? Okay, and so on. So practice this, guys. Just watch the recordings once again. Yeah, you can use a negative value also. So let's say I use minus 220. I will use minus 20 minus 49, let's say. Then if you draw the box plot, oops, what happened? Oh, I forgot to write this x here. Yeah, you can do with negative values also. Now your box plot looks like this. Your average first, I think something is wrong. Wait 1 second. This is your x. Okay, your x is like this. And now you are drawing box plot of x. Okay, it looks like this. So your boxes are basically okay. It is not showing below 0. It is not going. Just give me a moment, guys. Yeah, it looks like this now. So it will work. It will work with below 0 values also. So now minus 500 is your outlier. Okay. Yeah, it will change, Vishal. Exactly. Your IQR, everything will change now. Your IQR will accordingly change if you give negative values. The moment you change your X, your IQR 50th percentile, 25th percentile, everything will change. So if you have this now see your median has become 3. If you calculate these percentiles, your 25th percentile is negative number now. 50th percentile is 3, 75th percentile is 5, 95th percentile is 640, and so on. So all your values will change, and accordingly box plot will also change. Okay, so let me change the values to the original value, else you will get confused. Okay, so this is all about box plot. No, Jagdish, you cannot increase the granularity of box plot. This is, see, this has a different purpose. The purpose of box plot is to identify outliers. It is not to study the distribution of variable. It is just to identify which are the points which are outliers. And this will help us later in our analysis. When we go to machine learning, outliers, they have a negative effect on your algorithm. Whatever algorithms you use for machine learning, outliers, they basically distract your algorithm. This is like noise in your data. Okay, so your data has signal and your data has noise. Signal is something positive. Signal is the pattern in your business. Okay, but noise is something random, some random events that happen in your business. So those are noise. That is known as noise in machine learning jargon. So your data has signal, your data has noise. As a data scientist, your job is to identify the signal and ignore the noise. Okay, so outliers are nothing but the noise in your data. So we have to first identify them and then ignore them. So box plot helps us to do that. We will see that later in details. So guys, just revise this once, okay? I will share the recordings. Go through the recordings once again. So the recordings will be on YouTube. Yeah, you can play it at 2x speed or 1x speed, whatever is comfortable with you. So play it at a 1.5x speed or at 2x speed, so that you won't have to spend 3 hours watching the video, because you have already attended the class. So you can quickly run through the video and just try to understand. Okay, try to do that. That will save time for you. So this is all I had for today. Let's do a quick revision of whatever we covered. Okay, so that is how the class will go. Okay, first 10-15 minutes we will spend revising whatever was covered in the previous day class. So today was the first day, so we did not spend anything revising, but otherwise that is how the pattern is of a class. Okay, so first 15 minutes we do a revision. Okay, then we proceed ahead with the class, and last 15 minutes we again do a revision of whatever was covered in the current day class. Okay, so this is how we proceed. So let me open a new sheet and we will do a quick revision and wind up by 11, or maybe 5 minutes will extend. Okay, okay guys, so let's do a revision. So what did we see today? What did we see? Help me guys in revising. What did we see from the beginning? Yeah, the skills required, we are okay with that. We don't have to revise that. Yeah, of course we installed R. Okay, so the first thing that we saw was how do we check the working directory. So what is the current working directory in R? We checked that, right? So the function that we use to check the working directory is get working directory. Okay, get wd will show you the current home directory. Okay, the current home directory, get working directory, this command will give you that by default which folder are you present in. Okay, so if you want to change that folder, you can give set working directory and you can give the location. Okay, set working directory and you can pass the location. Okay, just make sure you give double backslash. You follow Unix syntax. Just make sure you do the Unix syntax and not Windows syntax. Okay, so this is what we started with. Next, what did we see after this? Let's go back. We saw how do we install packages. So how do we install packages? We use this function install dot packages. We write the name of the package. Okay, whatever is the name of the package, we install this package. You need to have internet access to install packages. Okay, so once the package is installed on your system, you will have to load the package before you start using it. Okay, so to load the package, we write library and we write the name of the package. Okay, so this you have to do every time you restart your R. You will have to do this every time you restart your R session. You will have to load all the libraries, but installation is only once. This is done only once. It will be on your system forever, but loading you will have to do every time you restart your R session. Okay, so that's about installing your packages. Next, what did we see? Yeah, I think next we moved on to, we saw how do we get help in R. We just write question mark and name of the package, name of the function on which we want help. Okay, we saw that. Then we saw the basic operators. Basic operators, it is pretty simple. I will not revise that. Same basic operators are used. We saw some built-in functions, length function. Then we saw the maximum function, mean function, and so on, median function, and so on. And then finally we came to data structures. So we saw only one data structure today. We saw what is vectors. So vector is nothing but collection of elements of same data type. Okay, collection of elements of same data type. So it should either be all numbers or it should be all strings. Okay, it cannot be a mixture of the two. If you give a mixture of the two, what happens? R converts the numbers to characters. Okay, that is your vector. Then we saw the indexing in vectors. How does indexing works? Indexing, it starts from 1. Okay, indexing in vector starts from 1. In some languages it starts from 0. So for example Python, in Python it starts from 0. Okay, so if you have a vector, you define a vector using the combine function small c, and you put whatever elements you want to combine in first bracket separated by commas. Okay, so this is a vector. The indexing in the vectors, it starts from 1. So this is 1, this is 2, this is 3, this is 4. And how do you use indexing? You use square brackets for it. Okay, always square brackets. And if you want to access only one element, you can write just that element, or if you want to access multiple elements, you can use the combine function. So let's say I want to access the first element and the fourth element, so I will write this. The output of this will be 1 and 11. Okay, 1 is the first element and 11 is the element at index 4. Okay, is this clear, guys? Okay, what else did we see apart from this? Okay, next we move to histograms. Yeah, we saw the sequence function also. So sequence function is pretty simple. You just give a starting number, the minimum number, the maximum number, and you give the increment. With what number do you want an increment? Okay, so this is very similar to the colon operator. Colon operator also does the same, but here the increment is always 1. Okay, in colon the increment is always 1. Here you have an option to give whatever you want. So you can give -1, 2, 3, whatever. But here it will always be 1 by default. Okay, so that's the sequence and the colon function. Next we move to histograms. Histogram is always done for one variable. Okay, it is always done for one variable. It shows the distribution of the variable. It shows the distribution of the variable. So x-axis is your variable, x-axis is the variable, and y-axis is the, what is on the y-axis, guys? Yes, the frequency or the counts. Okay, that is on the y-axis. This is a histogram. So the syntax for drawing a histogram is R is hist, and then the vector, and there are optional parameters like breaks. You can give breaks. So we saw what is a break. Breaks decides the granularity. Okay, breaks decides the granularity of your histogram. Then other optional parameters are xlab, then ylab, and then main. This is for x-axis label, this is for y-axis label, this is for title of the entire histogram. Okay, that's your histogram function. Then we saw another important concept, which is that of the box plots. So box plot, the application, why is it used? To identify outliers. Okay, to identify outliers. How do we do that? So we basically calculate the different percentiles, Q1, Q2 and Q3. Q1 is 25th percentile, Q2 is 50th percentile, more commonly known as median, Q3 is 75th percentile. Okay, so what do? We basically draw a plot which looks like this. Okay, which will look like this. So the median is always in the middle of the box. This is your Q2, this is your Q1, this is your Q3, and here the variable is on the y-axis. Okay, This is your variable. X-axis is nothing. There is nothing on the x-axis. It just has one axis, which is y-axis. Okay. So this distance is known as interquantile range. So interquantile range is this distance IQR. What is the value of that distance? It is nothing but Q3 minus Q1. Okay. Once you calculate that, you can identify this particular value. So this value is Q1 minus 1.5 times IQR. Similarly, this value is nothing but Q3. So from Q3 till here we know we are at Q3. From here we just have to add this distance. So Q3 plus 1.5 times IQR. Similarly, we already know where Q1 is. We just have to go down, and how much down we will go? We will go 1.5 times IQR. And whatever is outside this or whatever is below this is outlier. So your outliers are anything which is below Q1 minus 1.5 times IQR, or anything which is above Q3 plus 1.5 times IQR. Okay. So this is what you get in box plot. Now these will work in box plot also. Okay guys. Okay, y xlab will not work in box plot because there is no xlab, but ylab and main will work in box plot also. So you can give this while drawing box plot also. Okay. The syntax to draw box plot is very simple. Just write box plot and give x as the variable basically. Okay. Anything else guys? What else did we cover? Descriptive statistics, it includes the minimum, maximum, the median, the first quantile, the third quantile. This is nothing but descriptive statistics. Okay. And what is univariate analysis? It's very simple. Whatever we did till now was basically univariate analysis. Univariate analysis. Uni means one, right? So when you analyze one variable, when you analyze or when you study one variable, it is called univariate analysis. So remember, when you drew a histogram, you studied only one variable, right? So it was univariate analysis. When you drew box plot, again you studied one variable, so that was also a univariate analysis. Later we will see bivariate analysis, where we will have two variables. So we will have one variable, let's say age, on the x-axis, and we will have income on y-axis. This is bivariate analysis, because we are studying two variables simultaneously. Okay, that we will go later, but right now we are only looking at ways to study one single variable at a time. So histogram, box plot, we studied one variable at a time. So these are nothing but univariate analysis. Okay. Okay guys, are you clear with the concepts that was covered today?